I want to go through some basic integration rules with you. And again, this is a great handout that you already have in your notebook, so please feel free to reference it. But essentially what I'm saying is if I have the derivative of a constant, obviously the derivative is 0, so this is the differentiation side. If I integrate a constant, if I integrate 0, then that must have been just a constant. So see how they're just opposites of one another. If I take the derivative of kx, remember I could have moved that k to the outside, and I just get k because the derivative of x is 1. So if I integrate k, then obviously I'm going to end up with k times x plus c. And again, that's just that power rule that we talked about. And that continues. So if I have k times some function, if I integrate k times some function, it's k. That's that same rule that says, hey, we can move this guy to the outside. So this guy can pop out here. If I have two functions, I can find the derivative of the two functions in the same way I can find the integral of two functions. And then, of course, this one's our favorite, power rule for derivatives and for integrals. Here are some more. Obviously, these have everything to do with your trig functions, which hopefully you have already memorized this side of your table by now. But if not, keep going. It's going to help you a lot. And then, of course, we have the integration, which is just the opposite of those. Keep in mind that we're always adding plus c. So essentially, when we're integrating, first thing we're going to do is we're going to rewrite any fractions as negative exponents, the same way we did. This is the process we went through when we found the derivative. We want to rewrite fractions as negative exponents, rewrite roots as fractional exponents, multiply any products and divide any quotients, and then we integrate. So for instance, my first one, I would write that instead of as 1 over x cubed, I would write it as x to the negative 3. So I wrote the fraction as a negative exponent. Now I'm going to integrate. I'm going to use that power rule. Don't get confused just because it's a negative exponent. I'm going to take 1 degree more and divide by that degree. And then I'm going to rewrite it back in a form that makes sense. So negative 1 over 2x squared plus c. Same thing for the next one. This is the square root of x. So of course I'm going to rewrite that as the integral of x to the 1/2. It looks like I forgot my dx. Make sure you remember that dx because again, that's telling us we're integrating with respect to x. Then we integrate. So again, I'm going to take a degree more and then divide it by that. So a degree more would be 1/2 plus 1, or 3/2. And notice then I've divided by 3/2. And then I'm going to simplify. 2/3 x to the 3/2 plus c. And it's okay to leave it like this. If you wrote 2/3 and then the, whoops, I have that backwards, the cubed root or the square root of x cubed plus c, that would also be a correct answer.